All right, guys, working on quiz review number 2 here. We're going to go through it, see how we do. As always, our quadrilateral tree going to be very important. Quadrilaterals, trapezoids, kites. Trapezoids go to isosceles, trapezoids, and parallelograms. Those create the rectangle. These create the rhombus. And ultimately, we get the square. Please note all these connections. I've seen people, as of today even, not drawing this line or not drawing that line or not drawing that line. All of these are interconnected. They all flow into each other. So kites are rhombuses. Here are my kites. Here are my rhombuses. I have a kite that is not a rhombus. So can a kite be a rhombus? Yes. Does it have to? No. That is sometimes. Rectangles are parallelograms. Here are my rectangles. Here are my parallelograms. Is every rectangle a parallelogram? Yes, it is. So that is always. The diagonals of a kite are perpendicular. Diagonals are perpendicular. That is the kite property. So a kite is a kite? Yes, always. The base angles are congruent. It is an isosceles trapezoid property, and it's a parallelogram. So we're talking about an isosceles trapezoid and a parallelogram. So does a parallelogram, is that true? So here's my parallelograms. Are the base angles always congruent on a parallelogram? No. Can they be? Yes. So some parallelograms have that property while some don't. So that is going to be sometimes. A kite, so we know it has to be a kite with congruent diagonals. So we're talking about the kite family, and here are my congruent diagonals. That's isosceles trapezoid. So what do you call a kite with congruent diagonals? It's called a square if I was naming it. But can a kite have congruent diagonals? Yes. If I keep reading it, a kite with congruent diagonals is a rhombus. Well, this is code for a square. So a kite with congruent diagonals is a square. Is a square a rhombus? Yes, always. Always. If the diagonals of a quadrilateral bisect the vertices, that is code for rhombus, then they also bisect each other. That's a parallelogram. So we're basically saying a rhombus is a parallelogram. A rhombus, are those parallelograms? Yes, every rhombus is in the parallelogram family. So that is always. The diagonals are perpendicular. The diagonals of a trapezoid are perpendicular. Here are perpendicular diagonals, and here are trapezoids. That is code for a rhombus. So the diagonals of a trapezoid are perpendicular. That's a rhombus. Then they are congruent. Diagonals are congruent. So we're basically saying we're working with a rhombus. Here are my congruent diagonals. Is that every rhombus? Some rhombuses or no rhombuses. There's one shape that is also a rhombus. So it does happen one time, the square. So can it happen? Yes, it can happen in a square. So that is sometimes. Polygon questions. You need to know 3 things. We've talked about this a lot. You need to know that the interior sum is n minus 2 times 180. You need to know that the exterior sum is always 360. And you need to know that I plus E equals 180 at every vertex. From there, we can figure out all of these. So a polygon with 27 sides would be 25, that's 27 minus 2, times 180, and that equals 4,500. Let me make sure I got that right. 25 times 180, perfect. A polygon with 1980 degrees, well, I'm telling you how many degrees it has. That implies interior sum. The exterior sum is always 360, so we know it's not that. So we're talking about this situation. If I were to write it out algebraically, we know that n minus 2 times 180 equals 1980. How do you solve that? You divide by 180 to cancel out the 180, and then you add 2 to cancel out the 2. 1980 divided by 180 plus 2 is 13. Perfect. A regular, so it's a regular polygon, and this is one interior angle. What is the total degrees? So this is tough. It's about what do I have and what do I need? Well, to get total degrees, I know that's going to be n minus 2 times 180. So I need n. How do I get n? The easiest way to get n is through E, exterior angles. So what I would say is that I know that 178.75 plus E has to equal 180. Remember, I plus E is 180. So we know that E is equal to 1.25 degrees. right? Make sure I did that right in my head, but I think I did. 178.75, 1.25. How many degrees do the exterior angles add up to? So like this is what I mean when I say logic yourself through a question. You need to figure out what you need. I need N to answer this question. What do I have? I have I. What can I do with I? I can change it to E. What can I do with E? Well, if there's 360 total degrees and they're 1.25 degrees each, I need to figure out how many of them there are. That is 288. That is N. That's how many there are. So if there's 288 sides, then I can do 286 times 180, and that's how many total degrees are inside this shape. And that's 51,480. So that is our answer. A regular polygon has an exterior, that's just every polygon. The exterior sum is 360. And then a regular polygon with exterior angles that measure 4.5. So that's a shorter version of what we did up here. We know E, we want N. Well, what do the E's add up to? They add up to 360. One of them is 4.5. So how many of them are there? That's the question. 360 divided by 4.5 each. There are 80 of them. That is N, which is what we were wanting, the number of sides. A trapezoid has bases that measure this and this. The mid-segment is that. We know that base 1 plus base 2 divided by 2 equals the mid-segment. It is the average of the bases. So 2x plus 7 plus 5x minus 2 divided by 2 equals the mid-segment 4x minus 1. Quick sidebar, I've showed this in class at least once, but if I said 20 divided by 2 equals 10, that's true. When I do times 2 to both sides, the 2's cancel out, leaving me with 20, and over here I have 20. Something I see people doing is that they will get rid of the 2 on bottom like this, but then they'll also double the top. Well, if I doubled that, now I have 40. Does 40 equal 20? No. You don't double the top and the bottom like that. No, no, no. We're multiplying by 2 over 1. These 2's canceled out, and the 2 is gone. So when I do that move over here, when I multiply this side by 2, the 2's cancel out, and they're gone. And on top, I'm left with 7x minus or plus 5. Now, if I multiply that side by 2 to keep it equal, I have to multiply this side by 2. And I have to multiply the entire side by 2. Another big mistake is people forget to double this number. Please keep in mind you have to double the entire side. All right, and now I can solve this x equals 7, bada bing, bada boom. If x is 7, this would be 28 minus 1, which would be 27, which is what we're looking for, right? I took 7 and plugged it in for x. And that's what they asked for. How big is the mid-segment? So we could have answered anything they wanted from there. ABEF is a parallelogram. Okay, so ABEF is a parallelogram. So if that's 16, this is 16. That's really all we can do with that. CDEF is a parallelogram. CDEF, okay. So if this corner is 135, we can do some work. That would make this corner 45. Opposite corner, this would also be 45, but I'm just focusing on the parallelogram CDEF. Opposite angles are equal. If this is 135, then that's also 135. So what would 135 minus 75 be? Don't want to mess that up. Why is my brain not functioning? 60. Got it. Well, 60 and 40, that's 105. That would make this corner 75, which would make sense because these lines would be parallel. So those are alternate interior angles. Perfect. Oh, and if this is 16, this would also be 16, right? Opposite sides are equal. Okay. So these two sides are equal because of this parallelogram. And then these two sides are equal because of this parallelogram. Nifty. All right. And then they just gave us the same details. Okay, what's the question? Okay, sorry, down here. So it says, find the measure of angle ABC. So ABC would be this corner, A to B to C. Ooh, all right. Well, We know that this line is parallel to this one, and this line is parallel to this one, so we would know these two lines are in fact parallel. So if those are parallel, alternate interior angles, that angle would have to be 135. So that's one way to get it. Another way to get it is you could know that these two lines are parallel. So this is 45, right? Alternate interior angles, parallelogram. And then these two angles would have to add up to 180. That's another way to get to the same answer there. Oops. So this could be 45. There we go. DC, well, we got DC, that was 16 over there. And then angle BAF, opposite angles are equal, so that's got to be 60. Okay, so we answered a lot of those questions just by filling stuff out as we got them. Super challenge, round to the nearest thousands. How long is AF? I'm going to call that X. Let's give this some thought. If I draw this triangle over here, this triangle is called A, B, F. This is X. I know I have 60. Oh, I like 60. So if I know this side's 16. I want to keep that side intact. So I could drop a line like this. And if that's 60, 90, this would be 30. So this would be 8. This would be 8 root 3. 30, 60, 90 rules, right? So this 60, just to be clear, is this corner. So 30, 60, 90 rules. If that's 16, I drop my own height there. How big is the other corner? I need to know how big this corner is. What is that? So this would be 75. So this corner is 75, leaving me with 15. What can we do? So I'm going to call, so if I focus on this blue triangle, I need this part. I'm going to call it Y. So I'm going to draw just the blue triangle. So a triangle within a triangle within a triangle. Yikes. Yeah, this is hard. So draw that blue triangle. We know that this is 8 root 3. We know that this is 15, and I need this number. So that would be the tangent of 15 equals y over 8 root 3. So that y value would equal 8 root 3 tangent 15. And then this part is 8. So that plus 8 would give me x. So x equals 8 root 3 tangent 15 plus 8. I'm feeling pretty confident about that. I'm going to type it in, see if it's the answer I have here. 8 root 3 times the tangent of 15 plus 8. Make it a decimal. I got 11.713. Perfect. Yeah, I think there's a couple more ways we could have cut that up, but I made it into 30, 60, 90s. I got my special. Yeah, that's a fun one. Hopefully you try that one without watching the video. I should have said that before I started. Yeah, especially if you've been doing really well. That's a good challenge. All right, given the following trapezoid, names matter. It did not say isosceles trapezoid. It said trapezoid. Solve for x and y. Round x to the nearest whole number, but keep y exact. Okay, so trapezoid strategy really often is going to involve cutting off the wings. We like to cut off wings. That would create a 30, 60, 90 over here. So if that's a 30, 60, 90, and this is also 30, that would be half of 30 is 15, and this would be 15 root 3, which would carry over here. Now notice they said it was just a trapezoid, not an isosceles trapezoid. If it was an isosceles trapezoid, these would be the same size, and they're not. So we're going to have to be careful here. But if we know that this middle section's 100, right, this section's 100, that would mean this section's 100, and this is 15, we can do 140 minus 100 minus 15. Well, that would be 40 minus 15 would be 25. So that would be 25. So we know that this length is 25. So what are the questions? We want x. Where is x? Oh, this corner. It says round to the nearest whole number. So focusing on this triangle, right, we have opposite adjacent. So the tangent of x equals opposite. Oh my goodness. Opposite over adjacent. Tangent of x equals opposite over adjacent. So x equals the inverse tangent of opposite over adjacent. So inverse tangent of, make sure you know how to type this into your calculator, 15 root 3 over 25, rounds to 46. Yep, feeling good about that. And then finally, y is going to be a Pythagorean theorem. So to solve for y is going to equal the square root of, make sure you know how to put this into your calculator. There's definitely a lot of people that would mess this up. So that would be square root of parentheses 15 root 3, close parentheses, square it, plus 25 squared. I got 10 root 13 when I did that work. Perfect, perfect, perfect. I'm feeling real good about that. Hopefully you are too. Yeah. Given the isosceles, words matter. So now that it's isosceles, now we have some more information. We do know that the legs are the same. We know that the base angles are the same. There's a lot of things we can do here. If it's isosceles, if this corner's x, this corner's also going to be x. If that's 40 root 2, this is also 40 root 2. If this middle section here is 40, 120 minus 40 equals 80. Divided by 2 equals 40. That means that we have 40, 40, and 40. Basically, all three sections across is 40 now. Because those triangles, if it's isosceles, you know that the wings are the same size. That's the way it has to work. So how can we solve for x and y? Well, we can focus on one of these triangles. Right? If I draw this triangle here, I can draw it somewhere else if it helps us see it. We have an x. We know that this is 40 root 2, and we know that this is 40. I hope we recognize that pattern. So this would also be 40 over here, and this would have to be a 45-degree angle. It's a 45, 45, 90. Well, if this corner is 45, then how big is this corner? We're going to have to ignore this line to do that. These two corners have to add up to 180. So 180 minus 45, that's the 135. Going back to this, if you were confused here, what if I gave you this triangle? What if I said this was 45 and this was 40 root 2? You would do 40 root 2 divided by root 2 and call this 40. Well, it works both ways. If you know it's 40 root 2 and 40, then you can be certain that this angle is 45. It works both ways. So that could be done without a calculator. If you did have a calculator, you could have said the cosine of x equals 40 over 40 root 2, and you could have said x equals the inverse cosine of 40 over 40 root 2. It's going to give you the same answer as long as you type it into the calculator right. Okay. Here we have several rectangles. If it looks like a rectangle, it is a rectangle. So lots of things look like rectangles. They are rectangles. Solve for HD. If you have AE, where's AE? So and AE, if CH is 12 root 2, so where's CH? Now they're mentioning CH, but it's not drawn. So let's draw CH real quick. CH would look like this, and they're telling us that CH is 12 root 2. Looking at this triangle, I'm going to draw it off to the side. I can already see what to do. 12 root 2, this side is 12, right? They tell us that. It's the same thing we just did. If that's 12 root 2 and that's 12, that's a 45, 45, 90. This is going to also be 12. So if this entire side is 12, that means this part has to be 9. They said this part's equal, so it's going to also be 9. Okay, so we have all that. GF is 3. So the end goal, oh gosh, this gets messy, huh? They want to know how long is DH or HD here. So look at this triangle. Do we have enough? Well, if this line is 12, guess what? Rectangles all over. This is also 12. So the big green line, where can I draw this out? We'll do it over here. We have a big green triangle where we know this side is 12. And we know this entire bottom. Look at the bottom here. From all the way across, we have 9, 3, and 9. That is going to be 21. And they want that hypotenuse there. So let's just go in the Wayback Machine. If we did this without a calculator, divide by 3 would be 4. Divide by 3 would be 7. So it'd be the square root of 49 plus 16, which is the square root of 65. But since we divided by 3, we need to multiply the 3 back in. And there's our answer. And because there's rectangles all over the place, this line is going to be the exact same size. Rectangles, 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 rectangles. Oh yeah, that's a great question. Love it. That's a hard question. In the following, we have a kite inscribed in a rectangle. So the outside shape is a rectangle and the inside shape is a kite. Solve for all that. If CD equals 10, well, if that part's 10, this is going to be 10. If I draw the diagonals, which are going to do for sure, this would be 10. Rules of kites, it's going to cut this in half. Remember, kites are folded in half on one direction. If they're marking those two sides equal, I know it folds left over right. That means this corner is cut in half. That means this corner is also cut in half. We know that it's a kite, so this is 90. We know that corner is 104, but if this much is 44, then this is going to be 46. 104 minus 46, well, 104 minus 6 would be 98. Minus 40 would be 58, which would mean this is also 46 and 58. Using our rules of, if this is 90, 58, 90 minus 50 is 40, minus 8 would be 32. So these are going to be 32s. All I did was use my reflection rules and my perpendicular rules to get all that. All right. So I filled in all that. So what are the things we want? I'm going to start labeling what we want. This is getting real messy. A lot of good questions on this. Man, whoever made this must be awesome. CD equals 10. So find DH. So DH is that whole thing. I'm going to call this X. DH equals 2X. I need to get X, though. So let's focus on this triangle where we have 44, 10, and what I just called X. So to get X, that would be the tangent of 44 equals X over 10. So X equals 10 tangent 44. So 2X equals 20 tan 44. Because these would both be X, right? This diagonal is folded in half. The other one's not, but that one is. So 20 tan 44, was it a round to anything? Round to the nearest thousandths if necessary. All right. 20 tan 44, I get 19.314. So DH equals 19.314. All right. Next thing they want is DB. Change colors here. DB. Where's B? Oh, so I'm going to call this side Y. So that would be this side. Well, same triangle. So DB is the next thing we want. So using adjacent hypotenuse, that's going to be cosine. So that would be the cosine of 44. The cosine of 44 equals adjacent 10 over hypotenuse y. So that's going to be 10 over the cosine of 44. And that's just y straight up. So 10 over the cosine of 44. And I get 13.902. And that is dB. So there's dB. And then the last thing they want is the measure of angle HFD. HFD is this corner. Oh, that's going to be 64. We already got that. So the rectangle part, not really used. Huh. I guess just the knowing that those are all 10. But yeah, okay, we got them. We definitely got them. Oh, let's see. I thought we were out of problems. I was going to be so sad. All right, got another one. ABCD is a rhombus. So if this is 5x plus 10 and the perimeter is 200, all of these are 5x plus 10. So I'm going to do 200 divided by 4 and get 50. So I can right away, I know that this equals 50. So 5x equals 40 and x equals 8. I don't know what I'm going to do with it, but there we go. Angle DAB is 30. Oh, I like 30s. I know you do too. If AB is 5x plus 10, find the measure of ADB. So I'm going to draw my diagonals and x. Guys, are we pretty much already done? This might not be. Okay, well, I won't say anything. Here we go. This is 15. So that means that this corner would be 75 if this has to be 90. That's just knowing the rules of the rhombus. Looks like we're done. This is ADB, 75. X is 8. Yeah. Rhombus rules. Rhombus rules. Oh, phew. If we went out on that one, square, we can make it look like a square. A, B, C, D. So we draw and we label correctly. The area, well, the area of a square is s squared, and they're saying that the area of the square is 2,000. So we need to take the square root of that. So 1s, when we say s, we mean side length. The square root of 2,000 equals one side. That's 20 root 5. So each side is 20 root 5. Find the length of AC. So let's draw AC. Well, it's a square. So what happens when we do a square? This is going to be a 45, 45, 90. So it's going to be 20 root 5 times root 2. That's going to be 20 root 10. So there's AC. And angle ABD. Angle ABD. Well, if I draw the other diagonal, angle ABD would be this guy, and that's going to be a 45-degree angle. No doubts about that one. Perfect. All right, most descriptive shape with the conditions. I'm going to make my tree real fast. That's not this one. Oh, what was I doing? Move this out of the way. I don't care about you right now. Put you up here. Maybe I'll use you. This is a totally different thing. This was given the condition. It says quadrilateral ABCD. So let's draw a quadrilateral ABCD. Not necessarily a rectangle or anything. Diagonals intersect, so it's called ABCD. And the diagonals intersect at E. My class is about to be in here. How many more problems do we have? Talking about running out of time. Oh, this is the last one. See if I can get it done real fast. If AC is perpendicular to BD, so if these are perpendicular, that would make it a kite. And AB is equal to BC. That's just a property of a kite, because a kite folds at half one direction. So that's just going to be a kite. Got it. If E is the midpoint of AC and BD, well, that means it cuts the diagonals in half. That's going to be a parallelogram. That's just a property of a parallelogram. Got it. If ABC, if this whole corner is equal to this whole corner, it could be a kite, could be a parallelogram, and angle BAD, this is 90, right? And BCD, this is 90. Well, if those two are 90, 360 minus 180 equals 180. And these two are equal. Well, if those two are equal, then they're also 90. Now they're all 90. So if these two are equal and these two are 90, then they're all 90. That's the only way to make that, only way that could be possible. So we are at a rectangle. Perfect. And then the diagonals bisect the vertices, so that's a rhombus. And AC is equal to BD. And the diagonals are equal. So it's a rhombus where the diagonals are equal. It's a rhombus where the diagonals are equal. That has to be a square. All right, team, just in time for the bell. People are going to be joining me in just a second. Love y'all. This is a good review. Hopefully we're getting better. I'll see you next time.